are going to be talking about cryptography and post-quantum computing in this room, which is the most of the exciting topics. However, before I start, the panel here, we have experts in cryptography from around the world who are focused on, both working on the standards and working with devices and so forth that utilize cryptography. Just very quickly, introduce yourselves, starting with you, Joachim.
My name is Joachim Vance. I work for Verifone. I exist in a quantum state of many roles within Verifone, and I'm Chief Security Architect.
Richard Kisley, IBM, Chief Engineer for our hardware security module product. And I'm also representing Susan Langford from Ingenico, Senior Cryptographer from Ingenico. So she was part of the panel originally, but wasn't able to join us today.
I'm Steve Bowles. I'm the Regional Security Officer for Ingenico here in North America, but I also have our global relationships with standards bodies throughout the world. So looking forward to this.
Okay, so before I ask the first question, I'm just going to set a little bit of context here. When we talk about quantum computing, we're not going to explain what that is because 20 minutes is not going to do it. But ultimately, we're talking about types of computers that work in a fundamentally different way that will potentially allow for the breaking of some of the cryptographic systems that we have fielded at the moment that are considered secure at the moment, but will be potentially insecure once we have what's called cryptographically relevant or cryptographically significant quantum computing. So when we're talking about the challenges that the industry faces at the moment in migrating across, what are the biggest challenges that your customers are seeing at the moment with just this whole kind of concept of quantum computing and so forth?
And, it's complicated, right? I mean, a lot of people don't even know how to spell quantum computing or understand what the issue is, and even if they do, they don't know where to start. I think that's the greatest difficulty that I've seen is they don't know where to start, and then how do you prioritize, transition to post-quantum cryptography when you have all these other things? Like we haven't even transitioned mostly to AES yet. So, everybody's trying to deal with key blocks even, which is a thing at the beginning of next year that we all have to transition to if you're doing key management. So having a kind of a balance of the priorities of where does post-quantum fit into that, AES transition, key blocks, et cetera, I think is a big challenge.
Richard?
Yeah, I think we were looking at migration from two aspects, from the AES migration that people are undertaking to the post-quantum cryptography migration that people are undertaking. And I think people right now for post-quantum cryptography, they're trying to figure out when do I invest and how much do I invest. I think a lot of people are still waiting to start their crypto inventory, and that's a place, I think everyone on this stage would say start now, and most people I see at conferences, at RSA, at these events, they say start now, but businesses are still saying, when do we really need to start? But of course, the answer is from us, start now. So so that's our answer. I think, and I have note cards, so I don't trust my memory, so I have note cards, so please forgive me for that.
Certainly a big part of that is how to start now, right? And you think about it with AES. AES was published in 2001. And we're still not making AES for PIN encryption. We're just starting to make use of AES for point-to-point encryption. So how long is it going to take us to actually get out the standards, get ourselves ready, let alone commit to investments and actually start the projects up?
And to that point, talking about migration, you're saying we need to start now. We need to think about this now. We need to be starting our crypto inventories. How do we do that? What is the best practices for people who are looking to, work into the future with, preparing themselves? What are the best practices for migration? I'll start with you first, Steve.
I think the first biggest step is inventory. We've got to go through and you've got to make sure you've got a clear understanding of all of the public-private key infrastructure that you're making use of today, and not just what it is, but where it is, all the different systems that you're interacting with. And make sure you've got a clear understanding of the different systems, the data it's protecting, where that data is being stored and in what form. I think working through those sorts of things at least allow you to put yourself in a spot where you can scope what your challenge is going to be to migrate once the infrastructure is in place to actually start preparations to get ready for that.
Richard?
So I think that there's a lot of tooling that can help you with starting that crypto inventory as well. And tooling helps us in so many areas. And don't be afraid to use tooling to assist you with finding your crypto inventory and creating that database of all the places where you have keys, where you have code that needs to change. And then when you do look at starting to recode, I think a best practice is to code for agility as much as possible. One thing Susan Langford says is change always costs. Change will have a cost, but standards will help, the protocol development will help, and if you code for agility, it will help you do that transition as cheaply as possible.
Joachim.
I think, inventory, that's really the name of the game. I 100% agree. And one way to do that is you've got to work with your team, because your team knows their systems better than anybody, right? And so you have to start having a conversation of where's RSA in my system, where's ECC in my system, and that'll get you some of the way. And so you have to have a plan and kind of look at that. And the rest of the way, you're going to have to start talking to vendors, because they're going to know as well what systems they have. I think that's a really big part of it. I'm a little concerned about crypto agility, though. It's like, I'm not against it. I think it's a buzzword that maybe doesn't mean a lot in practice, right? But there is aspects of crypto agility where you can implement in a way that accounts for change, right? Which is, I think, what we really mean by crypto agility, meaning as we start to look at our systems, how can we develop them in a way that if the algorithm changes, the change or the cost of change is small. So we will always want to find a way to reduce the cost of change, because we know with cryptography, you can even see the way the systems where we're moving from single DES to triple DES, which was designed as a very easy transition, is very painful. Triple DES to AES seems to be very painful. So thinking about how do we reduce the cost of change is important as we kind of upgrade our systems.
You were talking about crypto agility, and certainly, what's hidden underneath of the hood of crypto agility is just this basic idea that you've got the biggest possible key that you can possibly have in that system, so that whenever you want to move out other keys to it, that you've got that strength. And right now, that's 256 bits of encryption. So certainly, as you're starting to roll out new technologies, to be able to use AES 256 master keys, or that top level key, or the strongest elliptic curve keys that you can come up, that you can manage into your PKI, to have those in your system so that it allows you that opportunity to migrate at the appropriate time for the transaction data that you want to protect. I think that's going to be super important.
But I think that also, again, on crypto agility, the ideal case is probably you have a policy somewhere managed in a central area, and you say, well, I need to change this mechanism. You take an organizational decision with review, and you change that policy, and you get an update across the systems to the new suite of mechanisms. I don't know who's going to do that, but if you can get closer to that versus hard-coded algorithms at hard-coded strings, and some people have hard-coded keys, or did up until a few years ago, you'll be in a better place.
So, Joachim, you mentioned, and Steve, you mentioned as well, the fact that we are still using in a lot of places triple DES for pins. And you mentioned the migration from single DES to triple DES was intended to be a simple thing, and yet it took a long time, and we're still not necessarily there in terms of implementation for AES. Are there things we can learn from that migration that we have taken from single DES to triple DES to AES now, things that we should bear in mind whilst we're looking at migrating some of these asymmetric algorithms to post-quantum algorithms? How can we take best practices from what we've done in the past? We'll start with you, Joachim.
There's not an easy answer there at the end of the day, because every system's different. Every vendor is going to have a different way of implementing, or the difficulty of change is going to be different for whether it's the system's bespoke or a vendor is stuck and not upgrading as fast as you would like. So it can be very difficult. I think part of it is you got to start playing with things in your test environment now, right? As you have test environments to start to play with. There are already a lot of people that are playing around with AES for PIN and AES for data encryption in payments space. And it's not very different. I mean, AES Stuckput, which we all worked on AES Stuckput through the X9 standards groups, doesn't have a significant change from triple DES duct, but some of the fields might be slightly different. So being able to play with, oh, my KSN is a different size, okay, I need to account for that. Or my data encryption, because now triple DES is an 8-byte block, AES is a 16-byte block, so you're going to have different data sizes when you do the data encryption, although sometimes it might just line up at the same time, right? So you're gonna have to play around with it to understand, okay, how do my messages change? I mean, that's what most people are gonna have to deal with is, okay, what are my message structure gonna change? Or how do I make sure that my vendors are accounting for changes in message structure and message size? And then even the transition to post-quantum, it's going to be even different, right? Key sizes are markedly different. I mean, we think, RSA 4096, 3072 might be big in a certificate, but then when we get to post-quantum, it's going to be huge. And so we have to be able to account for, okay, the data sizes for things are going to change, and then start to plan around that. That's a big part of crypto agility, is making sure you don't have fixed data sizes, and you're accounting for changes in data sizes.
Okay, so one thing I want to clarify to the audience in case they don't know, we're talking about post-quantum cryptography and we're talking about AES as if they're different things. So I'm going to go to you, Richard, in terms of, should we be thinking about changing from AES? Is there going to be another algorithm instead of AES, or is AES kind of inherently quantum safe?
That's a great question.
Well, let's move on then.
I don't think, and again, I'm not a cryptographer, but my understanding from working in the standards groups with people that are cryptographers, and these gentlemen who are both smarter than I am, is AES is, especially even AES 128, is perfectly fine for the foreseeable future. And I don't see anyone starting a cryptography competition for a replacement for AES.
Correct, yes.
I mean, certainly I think this comes down, when we started talking about inventory, part of that inventory is doing a risk assessment of your data. When you talk about quantum computing and quantum safe algorithms, where's the risk? The risk is in the aggregation points of data, right? Where is data being collected? Where do you have mass amounts? And if you think about from a cryptanalysis perspective, it's always easier to break something when you have more data encrypted by a particular key. And that's why I strongly feel that, prioritizing those systems where you are doing the data aggregation, those centralized components that are critical to the back end. If anything, when we think about the next migration, the past migrations, we focused on the pointy end first, and the last things we're doing are the back end acquiring systems. And it almost feels like when we talk about quantum computing and putting in quantum safe algorithms, that we need to focus the other way back. And there may be a story there to say that 2-key triple DES duct put may be usable for years and years to come from the point of interaction back to the processing front end. But from there back, we're going to have to get advanced crypto into those spaces where the data is being aggregated, where it's being collected, and where the attackers are motivated to go and get the biggest bang for their buck if they actually have any success with this. Okay,
so you talked about data there. I'm using the American term now, or the Canadian term perhaps, data. Right? I would say data. Potato, potato. Anyway, we're talking about the keys that are used to encrypt, pins, card holder data, that sort of thing. Is that the only thing we should be focused on when we're doing these inventories of where we're using cryptography? Or there are potentially other areas where cryptography is used that we should be paying attention to when we're thinking of how we might migrate to post-quantum? I'll come back to you with that, Joachim.
So I think cryptography is used in places that we don't even think about. And it depends, like we're maybe, in our discussion, it sounds like we're talking about the payment flow, right? But if you think about your DSS background and the back end, what about your SSH keys? That's either ECC or RSA, right? What about passkeys? That's right now it's going to be ECC or RSA. What about back end systems to communicate to HTTP? S is going to be, TLS is going to be ECC or RSA. So there's a lot of different places we have to be looking, I think. I don't know if that's the point of your question, but there's a lot of different places that we don't even consider using cryptography in our systems, and we have to think about what's the transition going to be for everything, because authentication, at the end of the day, is based on public key cryptography in many ways, and so we have to solve those problems as well. Like we have to not just think about the payment infrastructure end to end, but over the overall protection of our infrastructure, not just the kind of the close-up pieces.
Okay, that's good, thank you. One more question, then we're going to get to a lightning round, which is the exciting part of the whole presentation. Of course, this has been more exciting as well. So device security is changing due to PCI, post-quantum, NIST, and so forth. As vendors, all of you, of POIs or HSMs and so forth, what are your biggest challenges at the moment? I'll start with you, Richard.
All right, referring back to the notes. But I think all the device vendors are facing, NIST just dropped 3 standards. And so the interesting thing is how fast do you get those into your device for device attestation to start with? How do I secure the proof that I am the device that you purchased using post-quantum cryptography? And so that's the race that's going on now. And then how do you change the protocols for communication between systems? How do you change the code signing infrastructure so that you can trust the firmware and software running on these devices? And that's where I think all of us are concerned next, and where I would advise other people to be. As Joachim said, look at the post-quantum cryptography roadmaps for your vendors, right? And we're definitely some of your vendors for some of this audience. So what are your vendors' post-quantum cryptography roadmaps? And it starts with device security. And let me go back to Susan and she was highlighting the challenges of, right, so it was device security and challenges in that area. And so there's kind of a tension between device security and agility. So you tend to build that in from the ground up, put those algorithms and keys in the secure room, and those processes are audited. They're not comfortable to change. The specifics of those processes are audited. So that has a natural tension with agility.
Okay, if I may, can I get to the lightning round now?
Yep.
Is that okay? Excellent. So I want to make sure I get to this because we have some exciting
I'm not going to get shocked at the lightning round, are we?
I'm just going to say, uh-oh.
Okay, so as you mentioned, NIST has finalized its post-quantum algorithms. So they're published now. I believe it's FIPS 203, 204, 205. Correct me if I'm wrong there. Which one of those? So this lightning round, the people have to answer either in one word or a sentence at most. We need to make it quick. So which one gets broken first, academically, potentially? One of the post-quantum algorithms or AES? Joachim?
Neither.
Richard?
I don't know. I like Joachim's answer, though.
Steve?
Technicality, one of the candidates is still being considered because there's still a handful of encryption mechanisms that are being looked at to enhance that suite of mechanisms.
If I can just add a little bit, I think that
What sentence?
if I could channel, again, I'm not a cryptographer, but if I could channel one, I would say statistically the newest algorithms are the most likely to get broken.
Okay, thank you. Okay, so speaking of this, breaking things, what year is RSA 2048, a modulus for RSA 2048 factorized? And second part of the question, is that by a quantum computer or is that using a traditional computer? I'm going to start with you, Steve.
Year. I'm going to say about 4 years out, and that's going to actually 4 years out,
4 years
and
out.
it's going to be a traditional computer.
Okay, interesting. Richard?
So IBM has a quantum cryptography roadmap, a quantum computer roadmap, and I'm just going to refer to that, and it's saying that 2033 is roughly the time frame where you will see a quantum computer that's relevant at that level.
Okay. Joachim?
Okay, I know your short answers. I've been always a long quantum roadmap kind of guy. Like I don't think it's going to be in the short term, and I've changed my mind recently. So I'm probably saying 2035 for a quantum computer for RSA 2048 or 1024, but before 2030 for a classical break. I think it's going to break classically before it breaks with a quantum.
Okay, interesting. So one of my next questions was about when we were going to get a cryptographically significant quantum computer. So I've heard from you two folks. I think your answer wasn't exactly that, so I just want to come back to you, Steve. First, the year we see a cryptographically significant quantum computer.
Ignoring Microsoft's announcements, I'm going to say that that's going to be 2030.
2030. Okay, interesting. Okay, here's a softball question. Should people be thinking about migration to post-quantum cryptography, yes or no? Joachim?
Yes.
Richard?
Yes.
Steve?
Yes.
Perfect. Okay. And now the hardest question of the whole panel. I hope you've prepared for this. We've been waiting for this question throughout the whole panel. Which is the better film, Sneakers or Hackers?
Sneakers, no question. But then War Games got to throw that in there too.
Richard?
I'll go with Sneakers. Robert Redford, it's a good movie.
Hackers is immensely memeable, immensely cringe, so I think we're unanimous here, and Sneakers is the better film. But Hackers is very entertaining.
There you go. And I agree with the whole panel here. Sneakers is a much better film, but they're both great films. So that is the end of our panel. I hope you have enjoyed it. I've certainly enjoyed delivering it, and certainly have you enjoyed sitting here and providing this information? It's been great.
Absolutely.
Can we thank our panel members, please?